everyone. Welcome to your fourth lesson on Chapter 2. Our objective for today is to solve equations with variables on each side. We're going to solve equations that also involve grouping symbols that probably have variables on both sides. And then the standards we're going to be working on are these standards. Let's check our vocab and then start our lesson. For our vocab today, we got one vocab word, and that's identity. And identity is an equation that's true for every valued variable. So what happens is if we solve an equation that has variables on both sides, if the left side equals the right side, and they're 100% identical, then and we don't have any variables, then chances are we have an identity. And you'll see what I'm talking about as we see one in this lesson. Let's go ahead and start our first example. So we're going to get rid of any number with a variable by multiplication or division. And here's just a little hint for you. It's always better to move the smaller variable to the larger variable. So I'm going to show you how this works. So first thing you want to do when solving an equation that has variables on both sides, you want to draw a line through your equal sign. This is going to separate our left side from our right side. Well, first start by looking at the variables. This variable, there's 5 c's. This variable, there's 7 c's. So I want to move the variables by adding or subtracting. But again, it's better to move the smaller one to the larger one, only because chances are if you move the smaller one to the larger one, you might not have to deal with negative numbers. So I know that 5c is smaller than 7c. So I asked myself, how would I get rid of a positive 5c? And we learned in previous lessons to get rid of something that's positive, we make it negative. So we're going to make this a negative 5c. And if I do this to one side, I have to do it to the other. Now, notice that I put the 5c under the other 5c. C's line up with c's. Variables line up with each other as long as they're matching, so that way we can combine them, because they're like terms. If I have 5 c's and I take away 5 c's, I now have no c's on the left side. So we can go ahead and cancel that out. But I still have 8, so I'm going to drop that 8 down. Equals, I have 7 c's, and I take away 5 c's, I now have 2 c's. And I'm going to drop this negative 2 down. So if you see what we just did there, we moved the variable from the left side now to the right side. So now there's only one side that has a variable, this side right here. Next thing, we're going to move the number that's by itself by adding or subtracting. And what I mean by itself, I mean on the same side of the variable. So we're going to say same side of variable. And I'm putting this in parentheses. So the same side of the variable. So if we look on the same side of the variable, the number that doesn't have a variable is a negative 2. If I cover up that C, that looks like negative 2. Well, to get rid of a negative 2 or a minus 2, I do the opposite. We're going to add 2. We're going to add 2. Negative 2 plus 2 is 0. So now we still have 2 c's equals 8 plus 2 is 10. So we did goal 1. We did goal 2. Now we're going to get rid of any number with the variable by multiplying or dividing. So we're going to get rid of this number that's with our letter C by multiplying or dividing. Well, this means 2 times C, so to get rid of multiplication, we do division. We're going to divide by 2, divide by 2. We get 1C is equal to 10 divided by 2, which is 5. So in this problem, our answer should be 5. And if this is the right answer, then when I put 5 in here, and I put 5 in here, the left side will be exactly the same as the right side. Well, let's look at that. If I have 8 plus 5 times 5, that's going to equal 7 times 5 minus 2. Well, 5 times 5 is 25. So I have 8 plus 25 equals 35 minus 2. 8 plus 25, that's 33. 35 minus 2, that's also 33. So in this case, when we put 5 in our equation on both sides where the variable is, we see that the left side does equal the right side. And this is the only time in mathematics that we can make our two sides equal. So the only answer that will make the left side equal to the right side is 5 And that's our answer for this problem. And we just checked it because 33 does equal 33, so left and right are equal. We got the right answer. Let's try another. In example 2, we're kind of doing the same thing. Let's start with goal 1. Goal 1 is we're going to move a variable. And to move a number, all we got to do is add it or subtract it. If we follow our star here, which is kind of like one of the main ideas, if we're going to move a number, it's always better to move the smaller variable to the larger variable, just because you won't typically have to deal with negatives. Just my opinion. If you don't like dealing with negatives, it's better to move the smaller one to the larger one. It's not guaranteed, but there's a good chance you might not have to deal with the negative if you do that. So start by looking at your variables. We see 9f's and we see 3f's. So all we got to do is establish which one's smaller. Well, 3f's is smaller. So I asked myself, how would I get rid of 3f's? Would I add 3f's or would I subtract 3f's? 3f's plus 3f's would be 6f's. So I can't add 3f's because that wouldn't get rid of it. We're going to subtract 3f's. And if I subtract 3 letter f's from one side, we subtract 3 letter f's from the other side. Again, the f's need to line up on the right, and the f's need to line up on the left. If you have 9f's and you take away 3f's, you still have 6f's. You still have this minus 6, so we're going to just drop that down because nothing's happened to that. We have 3f's minus 3f's. That equals 0, so we can go ahead and cancel that out, but we still have a positive 7. So this whole thing equals positive 7. Almost done already. Now, we're going to move the number by itself, but it's got to be on the same side of the variable. So we look. Well, this has a variable. This is a number by itself. So now we're going to move that. And again, to move numbers, add it or subtract it. So only look at that number. That's a negative 6. If I want to move it to the other side, I do the opposite of negative 6. So the opposite of a negative 6 is a plus 6. So we're going to add 6, and we're going to add 6. A negative 6 plus 6 cancels each other out. We now have 6 letter f's equals 7 plus 6. That's 13. So we're almost done. So we did this. Last step is we need to get rid of any number with the variable by multiplying or dividing. So we look. This number is with the variable. What is that number doing to the variable? A number next to a variable means multiplication. Get rid of it by doing the opposite. So we're going to get rid of multiplication by doing division. And we're going to get f equals 13 over 6. And this is really, well, 6 can multiply close to 13 without going over twice. And 6 times 2 is 12, so 13 minus 12, that's 1, 6. So our variable f is equal to 2 and 1 6. It's the same as this fraction here, 13 divided by 6, but I changed it to a mixed number by saying, okay, well, how many times can I multiply the bottom and get close to the top without going over? I could do that twice. That's where the whole number 2 comes into play. 2 times 6 is 12. So I take 13 and I minus 12. I only have 1 left. That's 1 out of 6. And so that's how I get my answer to changing to mixed numbers. Let's get moving. All right, in example 3, we're going to solve one that involves parentheses. So this is like one of our another goals is when we're solving ones that involve grouping symbols. So we're going to solve a problem that has variables on the left side and right side that involves grouping symbols. So our first step, anytime you have numbers next to parentheses, distribute. So our first thing we're going to do over here is we're going to distribute. And we learned in a previous lesson in chapter 1 that distribution means we take the number that's outside parentheses and we multiply it to the inside. I know that this looks scary to a lot of people because it's a fraction. You guys can do this. If we look at a fraction, we're taking 1/3 times 18. All we got to do is take this number here, the whole number, and we times it by the top of the fraction, so 18 times 1. So we're really multiplying by the top, but then we're going to divide by the bottom. So I drew a small multiplication sign and a small division sign. So I'm going to take 18 times 1, that's 18. 18 divided by 3, that's 6. So 1/3 times 18 is 6. We're going to do the same method whenever we go to the 12. We're going to take 1/3 and multiply it by 12. 1 times 12, that's 12. 12 divided by 3, that's 4. So when we take 1/3 times 18 plus 12q, we're going to get 6 plus 4q. And again, to multiply by a fraction, we multiplied by the top, but we divided by the bottom with our whole number, and we got that answer. Equals, well, we're going to distribute on the other side as well. 6 times 2, that's 12q. And 6 times -7, that's -42. So after we do distribution, we're back to doing problems the same way we were doing them before. So whenever you have grouping symbols, it's best to distribute first and then go back to what we were doing. So we're going to look for moving the variable, and we're going to move the one that's smaller. So we look at our two variables. We have 4q and 12q. 4 is smaller than 12, so we're going to get rid of the 4. Since that's a plus 4q, we're going to minus 4q. And if we do that to one side, we do that to the other, we get 6 equals 12q's minus 4q's. That's 8q's minus 42. So far, all we did was move the variable from the left side to the right side. Now we're going to move the number by itself by adding or subtracting. Again, it's on the same side as the variable. So the number that's by itself on the same side of the variable is this 42. And to move that, we're going to add it because it's the opposite of what we see. So we're going to add 42. Add 42. 6 plus 42, 48, equals 8 cubes. All right. So last thing we need to do is we need to get rid of the number with the variable, this one here, by dividing by it because it's multiplying. So we divide by 8. Divide by 8, and we get 48 divided by 8 is 6. So our variable is equal to 6. And that's our answer for this problem. All right, so in example 4, we're going to be solving another problem that deals with numbers outside of parentheses. So we're solving problems again by our second goal with grouping symbols and variables on both sides. So we're going to first step distribute. The number on the outside is going to multiply to each number on the inside. And I know on your previous quiz, a lot of you didn't show that the number on the outside was multiplying to each one. So I do recommend using arrows so that way you don't forget, because some of you did miss some questions because you could have just said that this number goes to this number goes to that number, and they're multiplying. 6 times 3r, that's 18r. 6 times a -4, that's -24, equals, I have a fraction again. So in this case, I'm going to use a calculator to help me out with the fraction, but I'm still going to approach it the same way because I know that 3 times 46 might make a bigger number, so we'll try this. So first thing we're going to do is we're going to take the top times 3, so 3 times 46, that's 138, and 138 divided by 8, this gives me 17.25r. So what I did was I took 3 times 46, and then I took that answer and divided by 8, and it gave me this. Now I'm going to take 3 times 8, which is 24, and 24 divided by 8 will bring me back to 3. So looking at this is my answer after I distribute. I have 18r's minus 24 equals 17.25r's plus 3. I'm going to draw a line through my equal sign because now this is where we're solving. Whenever we get to solving, we should always draw a line through our equal sign so we can separate left side from right side, because in math, whatever we do to one side, we have to do it to the other. So we're going to move variables by adding or subtracting. And again, it's important to move the one that is the smallest first. So I'm looking, this is 18, this is 17.25. I'm going to go ahead and get rid of that. So to get rid of it, I wouldn't add it, I would subtract it. And if I subtract it on one side, I subtract it on the other side. If I have $18 and I take away $17.25, I have 75 cents left. I'm going to drop down to minus 24. I know if I have $17.25 and I take away $17.25, I have nothing. Equals 3. So right now, we only have the variable on the left side, and that's a decimal, so chances are we might need a calculator to make the work a little bit easier for ourselves. We're going to get rid of the number that's by itself on the same side as the variable, so we're going to get rid of minus 24 by adding 24. And if we do that to one side, got to do it to the other. And I don't know why I wrote 27, it's 24. All right, a negative 24 plus 24 cancels out. So now the only thing on the left side is 0.75r equals 3 plus 24, that's 27. So here's where we're at. We have 0.75r equals 27, where 75 hundredths of some number equals 27. So what we're going to do is we're going to get rid of whatever this decimal is doing to the letter r. Since that decimal is next to it, that means that decimal is multiplying. So to get rid of multiplication, we're going to go ahead and do division. So we're going to divide by 0.75 on one side and divide by 0.75 on the other. This cancels out, and we get r equals, and I'm going to type this in my calculator, 27 divided by 0.75, r equals 36, and that's my final answer for this problem. I could plug that answer into the top, and I would see that the left side is equal to the right side. That's the best way to check your math, is anytime you need to, you put this answer right back in your original problem for that variable and see if you get a true statement. If it's a true statement, it's right. If it's not a true statement, then chances are you did something wrong, and that's where you should come up and ask me for help. Raise your hand, and I'll help you in class. All right? Let's keep moving. In example 5, we're going to see something different. This is something that's going to have a special solution. So pay attention to what we're doing in this problem. We're still going to solve it the same way, using the goals that we have here. But we're going to see something different, and I'll show you what that is once we get into this problem. So we had a number outside parentheses, and that means we're going to distribute. So 8 times 5c, that's 40c, and 8 times negative 2, that's negative 16. 10 times 32, that's 320, and 10 times 4c, that's a positive 40c. Okay, so the reason why we're going to have something special happening here is because if we look, we have 40c and we have 40c on both sides. So what this is saying is, if I have 40 of something and I take away 16, it's going to equal 320 of something, and I'm going to add 40 of that something to it. But that doesn't sound right. So what we're going to do is we're going to check what happens when we do goal 1. We're going to move the variable by adding or subtracting. Now in this case, we don't have to move the lower one because they're the same. We just pick which one we're going to move. So we draw a line through the equal sign, and I'm just going to move this one. To get rid of it, I'm going to subtract it, 40c minus 40c. And if I subtract it on one side, I have to subtract it on the other. Well, if I have 40c's and I take away 40c's, I have no c's left. So the only thing left on the left side is negative 16. Equals, well, I'm doing nothing to 320, so I'm going to go ahead and drop that down. And if I have 40c's and I take away 40c's, I have no c's left. So the big thing we got to do now is we got to look at the statement we have here. Looking at this statement, it says negative 16 equals 320. Is that a true statement or a false statement? Does negative 16 equal $320? If it does, then we got any answer would work for this. But in this case, negative 16 is not equal to 320. So go ahead and draw a line through your equal sign that says these are not equal, and say that this is a false statement. Since this is a false statement, our answer is no solution. This is one of those problems that we can't actually get a real answer for because a negative 16 will never equal 320. So, since this is a false statement, there's no answer to this problem. And notice that we had 40c equals 40c, but we had different numbers. Since we had different numbers, no solution is possible. We're going to see another one that probably deals with special solutions as we keep going. Example 6, we're still looking at some special solutions. We're going to distribute this to get our equation of what we're actually solving. So first thing, we take 4 times t, that's 4t. We take 4 times 20, that's 80, equals Now I'm going to take the fraction times 20. So 20 times 1, that's 20. 20 divided by 5, that's 4. So I have 4t. Do the same thing to 400. 400 times 1, that's 400. 400 divided by 5, that would be 40 divided by 5 is 8, add a 0, so 80. So, look at this problem here. We have 4t plus 80 equals 4t plus 80. Do they say the same statement? Yes, they do. Since they say the same statement, we're going to see another special case. So, it says the left side is equal to the right side. So what we're going to do is we're going to move the variable by adding or subtracting. So in this case, since they're the same variable, again, it doesn't matter which one we move. I'm going to move this 4t by subtracting it, and if I do it to one side, do it to the other. 4t's minus 4t's, these cancel out. And I have 80 left. 4t's minus 4t's, again, they cancel out, and I have 80 left again. Now in this case, does 80 equal 80? Is this a true statement? We had the same equation up here, and when we got rid of our variable, we have 80 equals 80. Since this expression creates something that's true, so this is a true statement because it creates something that's true. And since this is a true statement, instead of having no solutions, all real numbers are solutions. So in this case, because we had a true statement here, this means that we could plug in any number in the world, like 1, like 2, like 3, and as long as we plug that number in the left side and the right side, they're always going to be equal. So this is what we call an identity. An identity is any value for the variable will make a true statement. So it doesn't matter if we plug in the number 2 here. 4 times 2, that's 8. 8 plus 80, that's 88. Well, 4 times 2 is 8. 8 plus 80, that's 88. So when I plugged in 2, I got 88. So what that means is we can plug in any number in the world, and it's always going to make the left side equal to the right side. So all real numbers are a solution because we have a true statement where the left side is equal to the right side. And yeah, we can plug in whatever we want, and it will always be a true statement. So let's keep going. This is an example of an identity. Let's see what we can do for a few more problems. All right, so example 7, we got a couple more examples, probably about 4 or 5 more examples to do. Just practicing ideas of how to do some problems. It might be less, it might be more. We'll see how it goes. I feel like hopefully you guys are getting this. We're still following our goals, and we're seeing if there is solutions and if there isn't solutions, as well as when we get one solution. So we're going to go ahead and solve. 2 times 4a, that's 8a. 2 times 8, that's 16. Equals, now we're going to do this the same way. We're going to take 3 times the top. So 3 times 8 is 24. 24 divided by 3, that is 8. So we have 8a. And 3 times negative 10, that's negative 30. So just look at this problem now and look at our variables. We have 8a, we have 8a. We have a positive 16 and a negative 30. They don't look the same. So I'm probably going to have some type of solution, but let's go ahead and get rid of our variables. Subtract 8a, subtract 8a. This cancels out, and we got 16 equals negative 30. And we know that 16 is not equal to negative 30, so this one has no solution. And that's our answer for this problem. Since the left side is not equal to the right side, there's no solution. Again, we distributed, we saw up here that they look the same, but there's different numbers that aren't with the variable, and since that's the case, no solution is possible for this one. Let's keep going. Alright, so in this problem, we're going to go ahead and distribute. We've got example 8 going here. So we have another one that deals with numbers outside parentheses, and again, fractions. So we've worked on quite a few fractions. Fractions, all we do is take our whole number times the top, divide by the bottom, and we get our answer. So here we go again. 21 times 1, that's 21. 21 divided by 7, that's 3. So we have 3c. Do the same here. 56 times 1, that's 56. 56 divided by 7 is 8. Well, that was a negative 56. This is a positive, so we have a negative. Alright, try the next one. 3 times c, that's 3c. 3 times a negative 8, that's negative 24. Negative 24 divided by 3, negative 8. So, looking at this problem, we see 3c minus 8 equals 3c minus 8. They're exactly the same. So that means we should know that we have an identity here. Any value is going to work for this. But let's go ahead and just prove that it's an identity. We're going to subtract 3c, and we get negative 8 equals negative 8, which is true. So this is all real numbers work for this answer. Anything will be a true solution as long as we plug it in for the variable. As long as we do it to both sides, we get a true solution because a negative 8 equals negative 8. One thing to pay attention to is when you have no solution or when you have infinite solutions, the idea is when you're done, you don't have a variable to solve for. You are just looking at numbers. When we started earlier, we had a variable to solve for, and when we solved that variable, we only got one answer. So there's sometimes problems that we're going to get one answer. There's sometimes problems where there's nothing that works, and there's sometimes problems where everything works. So just pay attention to what you have at the very end, and that'll tell you how many solutions you can have. Let's do 2 more problems and call it a day. All right. Example 9, we're going to work on geometry that deals with solving equations that have variables on both sides. So this says find the value of h so the figures have the same area. So before you actually begin this, you need to know the formula for the area of a triangle. Hopefully you remember from previous grade levels, but the formula for the area of a triangle, area equals 1/2 your base times your height. Well, if we're going to say that these two triangles have the same area, we're going to actually put 2 equal statements on them. Well, I have the base, I have the height is h. So what we're trying to figure out on both of these triangles is how tall are they? So we have 1/2 the base, so in this case the base is 6, so it's 1/2 times 6 times h equals 1/2 times its base, 10. And since that's h minus 2, we're going to go ahead and put h minus 2 inside parentheses because that 10 is going to multiply by the half, or the height, but this height has 2 numbers. Since it has 2 numbers, this is where we got to put grouping symbols with that. So let's go ahead and simplify this down. Well, half of 6, that's 3. So we have 3 times our height equals half of 10 is 5. Alright, so kind of simplified it down just by taking the number on the outside times each other. Now we're going to distribute on the right side because we have grouping symbols. 5 times h, that's 5h. 5 times negative 2, that's negative 10, equals 3h's. Okay, almost done. Now, in this case, normally we move the variable that is smaller. But notice that we only have a variable on the left side, and we have a variable and a number on the right side. Since we have a variable and a number on the right side, and only a variable on the left side, we want to actually move the bigger variable. So to get rid of 5h's, we're going to subtract 5h's. And if you subtract 5h's on one side, you have to subtract 5h's on the other. If I have 3h's and I take away 5, I'm short by 2h's. So here's what we have. We have a negative 2 times the height equals negative 10. Last thing we got to do is get rid of that number that's multiplying by h by dividing. So we divide by negative 2, divide by negative 2, a negative divided by negative is a positive. We get h equals, a negative divided by negative is a positive, 10 divided by 2, that's 5. So the height of these triangles would be 5, or at least this one's height is 5. So I could check it and see if they are actually true. If I take half of 6, that's 3. 3 times 5, that's 15. Half of 10, that is 5. 5 minus 2, that's 3, and 3 times 5, that's 15. So when I plug in 5 for both of these h values, I get the same solution in them. And that's how I know I got the right answer. We'll do one more, and you guys are good for a day. Final example. We're working on geometry in a way that we're going to be solving it by setting two equations equal to each other. So it says find the value of x so the figures have the same area. So we need to know the area formula for both of these shapes. We have a rectangle, we have a triangle. Well, we already just did a triangle. The triangle's area is equal to 1/2 base times height, where a rectangle's area is equal to its length times its width. So we know the area of a rectangle, length times width, and we know the area of a triangle, base times height, but it's half of it. So what we're going to do is we're going to set this shape equal to that shape, and then we're going to solve them based on their formulas to see what x is. So first thing, we take its length, 6, times its width, x. So 6 times x, or 6 times something, is going to equal 1/2 times 4. And again, since we have x plus 4, we need to put that in parentheses. And it's not just one number, so we have to put that in parentheses. Now, let's go ahead and simplify some things. 6 times x, that's 6 x's, equals half of 4 is 2. So here's what we're at. Since we have a number next to parentheses, we're going to go ahead and distribute. 2 times x, that's 2x. 2 times 4, that's 8. So we have 6 of something equals 2 of something plus 8. Now we go ahead and solve. We're going to draw a line through our equal sign. We're going to get rid of the smaller variable in this case. So we're going to subtract 2 x's. Subtract 2 x's. 6 x's minus 2 x's is 4 x's equals 2 x's minus 2 x's is no x's. We have 8. And now to solve that, we're going to get rid of this 4, whatever it's doing to x, well, it's multiplying, so we're going to go ahead and divide, and we get x equals 8 divided by 4, which is 2. So if we use 2 as our number, it should create a true statement. Let's go ahead and check it. 6 times 2, that's 12. 2 plus 4, that's 6. 6 plus 4, that's 10. 2 plus 4 is 6. 6 times 4, that's 24, but half of 24 is 12. And 6 times 2 is 12. So when we plug in the number 2, we get 12 for the area of this shape, then we get 12 for the area of that shape. That means 2 is our right answer. You guys did awesome today. Make sure you like this video, smash that notification bell, and subscribe if you haven't subscribed. And I will see you in class on Tuesday.